Okay, so here's the video going over questions from assignment 11.3. Now, I did the first two problems in the lesson notes. So I didn't expect any votes for one or two, and I got no votes for one. I did get one vote for two, so it's a little suspicious. But I'm not going to do those because you can go back to the lesson for 11.3, and it was near the end of the lesson that I did those problems. So I'm going to go through, and I think, I might just do them all. So you can skip the problem if you don't have a question about it. So this is a lot of solving differential equations. So the first step is to separate the variables. So you want the y to get over with the dy, so you got to divide it. So it's in the denominator. You want the dx on the other side, so it ends up over there. You don't want your dx or dy in the denominator. It's the first critical step of solving differential equation. If you don't do that, whatever else you're doing doesn't make any sense. Integrate both sides. Natural log the absolute value of y. What's the derivative? What do you take derivative of that gives you secant squared? That is one of the ones you guys should know. Tangent x plus c. You need plus c. Now they gave you initial condition. X is 0, y is 5. So I would use that right now. Plug the 5 in for the y. 0 in for the x. Now you guys should be able to figure out what tangent 0 is. It's sine of 0 over cosine of 0. Sine of 0 is 1. Sine of 0 is 0. Cosine of 0 is 1. So that's just going to be 0. So c equals natural log of 5. So we're going to rewrite our answer with the c value in it. Natural log of absolute value of y equals tangent x plus natural log of 5. We're going to exponentiate both sides. We're going to get rid of, now we can use rules of exponents to break this up. And so that's going to be a 5. To get rid of the absolute value, you can do plus or minus. I'd put the 5 in front. Now, you need to pick one or the other, plus or the minus. So you plug x equals 0 and you should get positive 5 for y. So tangent 0 is 0, e to 0 is 1, 5 is 5. You want it to be positive. So your final answer is this. Now, because this is multiple choice, I guess we're going to go ahead and ignore the domain, even though usually we should find the domain. Now, do we see this answer here? There it is. So didn't have to do anything extra on that one to make our answer fit the multiple choice options. Number 4, you want to separate the variables. So the y ends up on the left-hand side, multiplying. You got to multiply by y to get rid of the y, right? Dx ends up over on the right side, x dx. Integrate both sides, y squared over 2 equals x squared over 2 plus c. Now, one suggestion I would give you is that when you do multiple choice, it's often helpful to look at the answer choices maybe right before you do the whole problem, because that gives you an idea of what you're going to try and make your answer look like. Now, let's find the c value, but you'll notice that I don't know if any of the answers have y by themselves. They look more like the equations of like circles or hyperbolas. I messed up right there. So we want to plug, this is your x, that's your y. So we're going to plug 4 in for y and 3 in for x. And so that's going to be 16 halves equals 9 halves plus c. So c equals, subtract 9 halves from both sides, 7 halves. And so I'm going to rewrite it. Y squared over 2 equals x squared over 2 plus 7 over 2. Now, none of the answers have halves, so I'm going to multiply everything by 2. And that cleans it up. They all have x squared and y squared on the left-hand side. Kind of like standard form. Well, I don't know. Yeah. So we could subtract x squared to the other side. And that might be an answer. Do you see when positive y squared minus x squared equals 7? Now there's a 7 squared, but that's not right. So maybe instead we need to multiply through by a negative, and that would give you x squared minus y squared equals negative 7. And that's the one I see. That's answer A. So sometimes multiple choice can be a little bit of an extra challenge to make it match the answers that they give you to choose from. Okay. Now, we could have tried to get y by itself. You would have done plus or minus the square root of x squared plus 7. We would have gone with the positive, but that answer wasn't one of our choices. We would have also needed to consider domain. This one definitely has domain issues. But since it's multiple choice, we'll go ahead and ignore that for right now. Now, no one asked for problem 5. So, I mean, I don't know if it was that easy. Dy over y equals cosine x dx. You can integrate both sides. Natural log the absolute value of y equals, when you take derivative, give you positive cosine, positive sine plus c. Here's your initial condition. Natural log of the absolute value of 3 equals sine of 0 plus c. Sine of 0 is 0, so c equals natural log of 3. You rewrite it. Natural log of the absolute value of y equals sine x plus natural log of 3. We're going to exponentiate both sides. And over here, we could use rules of exponents to break this up into e to the sine x times e to the natural log of 3. That'll become a 3. Get rid of the absolute values, plus or minus, put the 3 out front. We got to choose plus or minus. If you plug x equals 0 in, you should get positive 3 out. Sine of 0 is 0, e of 0 is 1, times 3 is 3. You want it to be positive. So that's our final answer. As far as domain issues, I don't think it has any, but I think it would be all reals. But since it's multiple choice, I guess we're going to go ahead and keep going. And it's fine. Now that answer is on there. Okay. Number 6 had a lot of questions. So separate the variables. The y ends up in the denominator on the left-hand side. E to the x dx. We're going to integrate both sides. Natural log of the absolute value of y equals, what's the antiderivative of e to the x? E to the x plus c. Let's use the initial condition to find the c value. Plug 3 in for y. 0 in for x. Now, maybe this is a mistake people make. E to 0 is not 0. That's 1. So c equals natural log of 3 minus 1. So we're going to rewrite it. Natural log of the absolute value of y equals e to the x plus natural log of 3 minus 1. We're going to exponentiate both sides, which is going to look kind of crazy. Absolute value of y equals e to the x times e to the natural log of 3 times e to the negative 1. We could break it up. That's going to give you a 3. So to get rid of the absolute value, you can do plus or minus. Probably put the 3 in front. Now we could write this e to the x minus 1. And then we want to decide if it's plus or minus. It's going to be plus. I don't see that answer on my list. So then maybe I need to get creative and think about how I could change this. I could break this up. I already did, and then put it back together. Another way to write that would be e to 3 e to the x over e to the first power. And I think that's d, right? So, I mean, this would have been good enough if it were for a response. Domain, I mean, just looking at it, there's no domain issues here. There's no domain issues at the original derivative, so the domain would be all reals. Number 7 had a lot of questions. So we have to separate the variables. Y squared ends up in the denominator. I'm going to leave the 2 on the right side. And then we're going to integrate both sides. Now this, I'm going to rewrite as y to the negative 2 dy. It's not going to be natural log. It's going to be power rule. Bump it up 1, divide by the new exponent. This is going to be 2x plus c. I think it would be worthwhile to rewrite it without negative exponents and then try and find the c value. So you have this xy pair, and plug negative 1 in for y, positive 1 in for x. This is going to be positive 1, so c is going to equal negative 1 because you're going to subtract 2. So we're going to go back to negative 1 over y equals 2x minus 1. Now I want to get, we've been asked, okay, I guess let me slow down. We weren't even asked to solve the differential equation, but they said if x equals 2, y equals what? Well, you're going to find the differential, you're going to solve the differential equation, find the solution, find the equation, and then you're going to plug x equals 2 into it to find your answer. So we could flip both sides, which is a trick I like to use if I want to get the variable out of the denominator. It's got to be a fraction equal fraction. One, you can't just flip separate terms. Multiply by the negative. So this looks good. There is, by the way, domain. Domain x cannot equal 1/2. Original problem, so the domain of this, you put an open dot at 1/2, and then you say your initial condition is at x equals 1. So that would be your domain visually. Not that we have to do that, but I guess that might be good. The x value they ask us for better be in this domain. So they said, okay, well, we're going to plug 2 in. So we're going to plug 2 in and figure out what y is. Negative 1 over 3, negative 1/3. Answer B. Okay. Number 8 is a graphing calculator problem. So a lot of questions on number 8. And remember what the notes on 11.3 also covered. It had more solving differential equations, which we've been doing for like tons of assignments already. But also exponential growth. And it says puppy weighs 2 pounds at birth, 3.5 pounds 2 months later. If the weight of the puppy during its first 6 months is increasing at a rate proportional to its current rate, that right there, that's describing exponential growth. That's exactly. Something is growing at a rate proportional to its current weight. Then how much will the puppy weigh when it's 3 months old? So that whole sentence is just telling you, hey, this is exponential. So you could rederive it. You could write this as, okay, well, its weight is increasing. We could call weight y dy dt at a rate proportional to its current weight. You could do that and then solve the exponential. We could just say, hey, this is exponential. So we know the answer is going to be y equals y naught e to the kt. I'm fine with that. You can do that on the calculus test if you encounter exponential growth. And there's 2 things we got to figure out. We got to figure out the k and the y sub 0. Now, y sub 0 could be at any initial condition. It doesn't have to be at time 0. But it does say 2 pounds at birth. So we could say, 2 pounds at birth is 2 when time is 0. So y naught equals 2. Does that make sense? But you got to find the k value. So you need another separate time and weight point that you can plug in here and then solve for k. So you got to find y naught first. So it says 3.5 pounds 2 months later. So 3.5 pounds 2 months later than what our time 0 was. So we're going to solve this we got to find k. So then we're going to take the natural log of both sides. To get rid of the e. And then k is going to be 1/2 natural log of 1.75. So that's your k value. So we finally have our exponential growth model with all the known values. So I'm just trying to come up with our equation. And now we can use that. How much will the puppy weigh when it's 3 months old? So we're going to plug 3 into it. For time. And that's the answer. But obviously our answers are in decimal. So this is where your calculator comes in handy. It doesn't even need to be a graphing calculator. 2 times e to the, now 2 times e to the 0.5 natural log 1.75 close the parentheses. We could just make this 1.5 because there's a 3 times the 1/2, so that's 3 halves, 1.5. However you want to enter it in, and we get 4.630. So it says, I don't know, 4.6 would be truncated. Seems like the best answer. So that was exponential growth. I mean, if you really want to, you could take this differential equation and solve it and get the exponential growth model. Or you can, if you recognize exponential growth, just use the solution that we have commonly used since Algebra 1. Number 9 had just a couple questions, so I'll just do it real quick. You need to separate the variables, integrate both sides, power rule on the right, plus c. Did they give us initial condition? Then y could be, it says y could be. Okay, well, let's just leave the c in there. Exponentiate. I'm going to use rules of exponents, break that up, and then I'm just going to call that a c. And then to get rid of the absolute value, you can do plus or minus. So I'm going to say plus or minus c e to the x cubed over 3. So I'm looking for an answer. Maybe I'm just going to look that has plus or minus a number times e to the x cubed over 3. And it says could be. So there's no plus 7. There's no natural log. There's no e to the 2x. There's no, just this is it right here. This has plus or minus some number times e to the x cubed over 3. So a little variation. Number 10 had a fair amount of questions. It says that's exponential growth, isn't it? You guys got to start recognizing that. dy dt equals ky. That's the definition of exponential growth as a derivative differential equation. K is a non-zero constant. Then y could be what? So we could just go off that like, hey, we know the answer is going to be y equals y naught e to the kt. Do you see one that has some number e to the kt? I mean, I would say B, right? You could solve the differential equation if you want, but we could also take advantage of multiple choice to, use what's in front of us. So it's got to be that, right? All right. Number 11 had a lot of questions. So what is the value of y when x equals 0? So this is kind of like one that we did earlier. We're going to solve the differential equation, find the function, and then use the function to find another answer. This is your initial condition that we're going to use to find the c value. So we've got to separate the variables, dy. Now, here's the interesting thing. You don't really have to separate the variables. I mean, you can put the dx on the right side, but there's no y stuff here. So it all stays on the right. We're going to integrate both sides. So we're just going to get y on the right, 1y. Now, this looks like a good opportunity for U-substitution. U equals cosine x. Remember, this is cosine x squared. So cosine x is clearly the function that seems to be inside another function. And then the derivative of it would be negative sine x dx, which is good because you see a sine x dx here. Now, we don't want the negative. So we're going to get negative cosine u, negative u squared du. We're going to replace cosine x with u. And sine x dx is du. So this is power rule, u cubed over 3 plus c. We need to change it back in terms of x before we find the c value. So that's going to be cosine x cubed over 3 plus c. Let's find the c value. So they gave us initial condition, y is 0 when x is pi over 2. Cosine pi over 2 is 0. You guys remember your cosine graph? That's 2 pi. That's pi. That's pi over 2. 0. So c equals 0. That worked out nice. So our answer is now y equals negative 1/3 cosine cubed x. That's the solution. Leave the domain and be all reals. We're going to plug 0 in for x. Cosine 0 is 1. And so we're going to get negative 1/3. So we had to solve a differential equation to find the solution and then use that solution to find another value in the function. All right, number 12, graphing calculator. At a glance, it's talking about populations and stuff like that. So I'm already thinking exponential growth. Population grows according to the equation. Okay, that's exponential growth. Where k is a constant, t is measured in years. If the population doubles every 10 years, then what's the value of k? So we're trying to find the k value. Now, we could go ahead and say, hey, we know that y equals y naught e to the kt because it's exponential growth. Or you could do the work to solve it and you'll get something like that. Now, we don't have an initial condition. We don't know any y, specific y, or we don't even know the initial population, but we have this thing that says doubles every 10 years. So exponential growth, a lot of times there's a very common term they call like doubling time. Or if it's exponential decay, they call it half-life, for like radioactivity. It's just kind of a number that gives you a good idea of how quickly it's growing. So it's going to double. So in 10 years, the initial population, we're going to have double it in 10 years. Now, remember, we're trying to find k, and we don't know why not, but why not goes away, cancels out. It's on both sides. So we're going to take natural log on both sides. That gets rid of the e and divide both sides by 10. And then this is where your calculator comes in. 1/10 natural log of 2 is 0.06931. So there you go. Hey. There you go. So it's good to recognize exponential growth. Whether they describe it in the sentence, whether they give you the differential equation, it saves you a little bit of time. And you can always rederive it. Now, there were some questions on 13, not a ton. Now, when we separate the variables, it's got to involve multiplication and division. So we're going to divide y plus 5 all together. That's the only way you're getting that 5 over the left-hand side without leaving other y stuff over here. And then the dx ends up over here. So it's going to be dy over y plus 5 equals x plus 2 dx. You need parentheses around the x plus 2. Don't necessarily need parentheses around the y plus 5 because it's all in the denominator. So these fractions already imply grouping. Now we're going to integrate both sides. Now this right here is an example of an inner function. We could do U-substitution, but the inner function, it's like y to the first power. So it's going to be natural log of the absolute value of y plus 5. The thing you would have to watch out for is if the derivative of what's inside gave you something extra on front, you would need an extra number or something to cancel it out. But the derivative of y plus 5 is 1. So you're good. You could say u equals y plus 5. du equals 1 dy, rewrite it as du over u equals natural log of the absolute value of u, and then replace u with y plus 5, and then there you go. That's a lot of work though. X squared over 2 plus 2x plus c, right? We just integrate term by term separately. Now we have an initial condition here, so we should try and find it. Natural log, you're going to plug in negative 4 in for y. We're going to plug 2 in for x. This is going to be natural log of 1, which is 0. This is going to be 4 over 2 is 2. This is going to be 4 plus c. C equals negative 6. So we're going to rewrite it. Natural log of the absolute value of y plus 5. Now this is not multiple choice. So we're definitely going to talk about domain here. 1/2 x squared plus 2x minus 6. And I'd get rid of natural log. And I think I'm just going to keep all this inside of one big E to that, because breaking it up is not going to help us make anything simpler. If there were some natural logs or whatever, then yeah, we do it. Now to get rid of the absolute values, you're going to do plus or minus. And it needs to be one or the other. So if we use our initial condition, if we plug 2 in for all the x's, we should get negative 4 for y. And the negative 4 would show up here. So if I plug 2 in, I get 4 over 2 is 2, plus 4 is 6, minus 6 is 0, e to the 0 is 1. And if I plug negative 4 in over here, I get 1. So we want positive. And then we need to get this 5 over the other side. So it's going to be e to the 1/2 x squared plus 2x minus 6, all inside the exponent, minus 5 separately. So that's your solution. Now domain, are there any values of x that would be a problem in here? Can you not raise e to certain powers of x? No, that's all good. So as far as domain goes, we check this and it's all reals. We also need to check the original derivative. Any x or y values cause problems there. Division by 0, imaginary, anything? Nope. So the answer is for negative infinity to positive infinity. This is required part of your answer. On multiple choice, maybe we don't need to put it because we're just trying to pick the right answer as quick as we can. So we kind of leave maybe some stuff out sometimes, but this is not multiple choice. So you need the domain on your first practice test. I'm going to give you one of these on free response, and if you don't give me a domain, you're losing the whole point for all the rest of the work after you found the C value. Just trying to get y by itself. That's usually tied in with the domain. So don't skip the domain. Number 14. Now, I think number 14 is kind of challenging because how do you separate x and y here with multiplication and division? You can't. So I'm surprised there aren't more questions on this one, because this one takes a little step of creativity. This is the same thing as e to the x times e to the negative y, right? Rules of exponents. And then you could write the e to the negative y as e to the y on the bottom. This is easier to figure out how to separate the variables now, because now I'm going to multiply e to the y to the left-hand side, the dx to the right-hand side. That little step right there, I would think a lot of people would not think of that right away. The antiderivative of e to the y is e to the y. The antiderivative of e to the x is e to the x plus c. Here's your initial condition. Plug 0 in. Plug 0 in. Now those are 1s, but then if you solve for c, c equals 0. And so we rewrite it, e to the y equals e to the x, and don't need to write the plus 0. Now we got to get y by itself. So you got to take the natural log of both sides. And you get y equals x. Wow, that's crazy. The solution is a line. What's the domain? If I don't see this in your work, this is all reals, but you also need to look up here. Are there any issues up here where x or y would cause some undefined value? Nope. So the domain is all reals. Now remember, the domains of these solutions, the differential equations, are a single open interval. This is a single open interval, but if for any reason there's a point that broke it up, we wouldn't necessarily give the domain like we typically would just for that answer by itself. We would make sure that we only give one chunk of it that contains the initial condition. Okay, and we're going to see a good one really soon. Number 15 isn't that one yet, though. 16 is kind of crazy. Now we got to separate the variables, so I'm going to divide the y squared to the right-hand side, the left-hand side. I'm going to leave the negative 2. I leave as much stuff on the right-hand side as possible. We're going to integrate both sides. Now, this is not natural log. This is y equals negative 2. So that's y to the negative 1 over negative 1. That's power rule. And this is going to be negative 2x squared over 2 plus c. Now, I would rewrite this as negative 1 over y. So without the negative exponents. I think that's going to be easier to do the work in my head. So here's your initial condition that we're going to plug in now so that we can find the c value. The y is 1/4. It's in the denominator. The x is 1. So we get negative 4 equals negative 1. The negative isn't getting squared, so it's still negative 1. And so c equals negative 3. So we rewrite it. Negative 1 over y equals negative x squared minus 3. Now I could flip both sides, but I got to flip it as a single fraction. So it's going to be y over negative 1 equals 1 over negative x squared minus 3. We can multiply both sides by negative 1. Now, I'm just looking at the simplest answer. I'm going to apply that negative 1 to everything on the bottom. So it's really nicely this. Now, we need to consider domain. And so domain, there's something here worrying me. And that would be the denominator. If you have a rational function, it often has vertical asymptotes where you divide by 0. So you know the bottom can't be 0. So maybe you should figure out where that happens. Plus or minus, it's imaginary. Now, I'm probably wanting to see that work. Otherwise, I'm going to think you just got lucky. But that doesn't affect us. Are there any domain issues with the original differential equation? Any way that derivative would be undefined? No. So our domain is all reals. Okay, now for the last problem. Definitely probably one of the crazier ones. We're running into this issue that we kind of had to deal with on problem 14, where we have x's and y's mixed in together as a single exponent. So we want to use rules of exponents to break them up so that we can break up the e to the y part to the left-hand side. So that's going to end up in the denominator. Everything else is going to stay over here. with the dx, and then we're going to integrate both sides. Now, we have a couple issues here. One, this is not natural log, and you need to realize this is e to the negative y. And the antiderivative of e to the negative y is e to the negative y. The antiderivative of e to anything is that thing, but you're going to get an extra negative popping out, so we need an extra negative to counteract it. You could do U-substitution if you thought you need to. U equals negative y, du equals negative dy. You don't want the negative. So you get negative e to the u du, and you get negative e to the u, and then replace u with negative y, and that's where we're at. Over here, at least we want to be thinking of chain rule. U substitution, u equals sine x, d equals cosine x dx. Perfect, right? So this is e to the u du, which is e to the u, which we got to rewrite with this plugged into it. I'm going to rewrite this side as negative 1 over e to the y equals e to the sine x plus c. Well, that's kind of messy. Let's find our c value right now. Negative 1 over e to the 0 equals e to the sine 0 plus c. Now, sine 0 is 0, but e to the 0 is 1. This is 1. C equals negative 2. So, rewrite our answer with our new c value. Now, we got to get y by itself. This is all algebra, but it can be one of the more tedious parts of the work on these kind of problems. Usually on first response, there's 1 point left for all the rest of the work you can do. So make sure you get all those points up there. That's all a lot of calculus. I'm going to, I don't know what I want to do with this. We could flip both sides. I didn't do it exactly like this in my solutions, but this will work. Multiply both sides by negative. Now to get rid of the e, you got to get rid of all the other stuff outside the e, and then you're going to take natural log of both sides. So there we go. We got y by itself. But now for the challenge. What's the domain? There's a lot of potential domain issues right here. We don't want division by 0. We don't want natural logs and negatives or 0. So there's a lot of different things that are going on here. One is, so I'm just going to write a little note to myself, domain question mark. So we e to the sine x minus 2 cannot equal 0. Also, by the way, it more specifically needs to be negative, so that the negative on the top makes it positive because you can't take natural logs and negatives. Now, the nice thing about this is that both of these are going to get taken care of in the same work. I don't really need to keep tabs on the inequality stuff because I know that my final answer is going to have to contain this initial condition. That'll point me to the one chunk of the graph I need. So e to the sine x equals 2. You're going to take natural log of both sides. You're going to take inverse sine of both sides. Okay, that's an x value that's not allowed in your domain, and that's kind of a weird value. We'll hold on to that for a second. Let's go up here and say, are there any values up here that are bad? Any values of x that you can't plug in cosine? No. Any values of e you can't raise? No. Any values of x you can't plug in sine? No. So there's actually no issues from the derivative. It's all tied to this. Now, I think the best thing we need to do is try and figure out about what value this is. Now, natural log, this is a little crazy. So I'd probably just, if we went ahead and used our calculator here, it'd be a lot easier. So I'm just going to say I probably wouldn't. I don't think you're going to have to do something that crazy. I think, we might be able to pull it off, but 0.7658. Make sure you're in radian mode. Now, by the way, this is principal value. So this is quadrant. It's going to give you quadrant 1 no matter what. Natural log of 2, by the way, this is a good way to estimate it. This is 1, 0. This is the natural log graph. So natural log of 2 is like here. Also, natural log of 2 is log base e of 2, which is asking you, what do you raise e2 to get to? And e is 2.71. And so what are you raising 2.71 to get to? It's probably a number that's a little smaller than 1, right? If it was to the 1, it'd be 2.7. If it was bigger, it'd be even bigger. So it's probably, somewhere between 0 and 1, which is actually good enough for us, because I would do a line check and say, okay, well, okay, I got to back up for a second. Inverse sine of some value between 0 and 1 would also be some small positive number. So I know that this value right here is a little bigger than 0, which means that 0 has to be here, and that's our initial condition, and this is our domain. Or you could use this value and be like, oh yeah, that's the value, and this is our initial condition, so this is our domain. Now, that's a picture of it. We need to write it, probably like an interval notation. So we're going to say negative infinity to inverse sine of natural log of 2. And the domain goes with the answer. Now, I got to hold on a second because I'm looking at my answers and I have something a little different. Okay. I have to think about this. I went back. Remember, this is giving you principal values. These answers for sine happen over and over again. This is quadrant 1. If I was showing you guys a little graph of the sine curve, and this is like 2 pi, this is pi, which is about 3 point whatever. So this is right around here. But remember, the graph keeps going, and it hits that value again back here. So I think we have to break it up there also. We need another open dot. And what would that value be? Well, it'd be this value. What's the distance right there? What's the period of sine? 2 pi. So I think we need to say inverse sine of natural log of 2 minus 2 pi would be the other edge of the domain. Yeah. Is that right? Oh, actually, gosh, keep finding mistakes. Actually, it hit the value right here, right? Because these values, quadrant 1, and then it hits it again in quadrant 2. So we would have to do, it's actually this same angle right here, but we'd subtract. Okay, so negative pi minus inverse sine of natural log of 2. All right. The fact that I made so many mistakes shows you. But that's just a good example of domain is an issue. So that's it. I hope that helped. We did all the problems.